Today, the object of our analysis is what we named digital asset. And what do we mean by a digital asset? Well, being digital refers to data information stored digitally, and being an asset refers to anything that can be owned and controlled to produce a positive economic value. Consequently, a digital asset refers to data and information we own and control and use to generate tangible benefits. The advent of digital assets has resulted even in the emergence of a new discipline, infonomics, taking care on how to measure, manage, and monetize digital assets. Building, managing, and measuring digital assets involve a set of challenges touching several aspects such as data quality, data integration, and data analytics. On the front of data analytics, we have today a wide range of flourishing technologies, including predictive analytics and forecasting, mostly based on machine learning techniques. And on the side of data integration, the related methodologies are quite standardized since many years ago. Instead, the aspect of data quality, despite everybody recognizes its relevance, it is often overlooked and considered something collateral and of secondary importance. Indeed, we in Pinsot consider data quality the solid foundation for every digital initiative, especially the ones aimed to provide prediction and forecasts to support business and operational decisions. We believe that consistent digital assets coupled with measurable data quality indicators are the base for an healthy investment on digital initiatives. The issues we have to face in producing digital assets are mostly depending on the data defects which can occur all along the data transformation chain. First, we all know that every piece of information we consider in our calculation comes with an intrinsic, unavoidable precision limitation. Then, when we analyze production and consumption around an envelope, we know that the measurements never add up. And moreover, such defects may be related to the instrumentation level, to the data acquisition infrastructure, and to inappropriate data calculation and transformation steps, as well as to human data manipulation. So we would like to automate the process as much as possible and make the curation of defect a sustainable practice, and use data quality indicators to drive investment back to the measurement system. For example, where should I place a new flow meter in my plant to maximize the outcome of my investment in new measurements? We also want to create a usable digital asset with a higher degree of accuracy and a lower possible degree of uncertainty, ready to be consumed by the digital value chain. To face the challenges above, Sigmafine relies on a model-driven data quality approach. So the center of the transformation process is a model. And what do we intend for a model? The model is the conceptualized representation of the subject of our analysis. It can embrace an entire production facility or a single process unit or an utility or distribution network. It embeds the engineering and operational expertise of the company and where required it includes even business and/or compliance rules. Such model is typically fed by the real-time data infrastructure with process data and where required with laboratory data, business transaction and more. And for all the reasons introduced above, we cannot ignore that each piece of data entering the transformation chain cannot be assumed to be exact or correct. It brings with it an inherent degree of uncertainty. To minimize the effect of such uncertainties around the model, Sigmafine runs a set of analytics whose objective function is to find a current solution minimizing the uncertainty of the resulting dataset. By the way, this has been the job of Sigmafine and its user for almost 3 decades now. The output of this transformation process is not just a union of multiple individual data streams, but the best statistical dataset approximating the true value of our measurement system. For those who know Sigmafine, in Sigmafine terminology, this is defined to be a case. Indeed, this is a digital asset embedding both the so-called reconciled measurement and the trackable statistical data quality indicators, which can be used and for several purposes, including but not limited to improve operational performance, to support accounting and finance duty, to feed predictive analytics tools. However, it is important to notice that this is not just a one-shot achievement, but it must be turned into a practice to be managed over time. So the set of cases or digital assets produced over time is the foundation for a validated, controlled, and measurable system of record for the company. And the adoption of a data quality practice is the one allowing to minimize the uncertainty, avoiding financial losses and maximize financial gains, which indeed brings us back to the definition of what a digital asset is. But how Sigmafine enables so many industries in adopting a data quality improvement process? At first, through data reconciliation, which constrains the data with first principle equations, such as conservation of mass, volume, energy, or component, while simultaneously minimizing the uncertainty associated with the measurements. On top of data reconciliation, tracking and genealogy capabilities allow to infer physical properties, grades, stream qualities, as well as ownership and other business categories. However, Sigmafine is not only a set of advanced analysis. Its foundation is an asset database which is fully configurable, customizable, and extensible to adapt to the needs and requirements of different industries. It can scale in size from very small models of few hundreds of assets to very large scenarios where models are composed of tens of thousands of assets. Finally, it provides seamless integration with the customer infrastructure, able to interfacing bidirectionally with disparate data sources and data repositories, such as historian, planning and scheduling system, movement system, ERPs, and business intelligence tools. But let's see a real case where Sigmafine is applied in a downstream for the energy monitoring of a crude distillation furnace. The raw dataset you can see on the left is used to study the correlation between measured oxygen in the flue gases and the furnace efficiency. As you can see, the raw dataset shows a very poor correlation because of the inaccuracy of the measured data. In this case, this company applied Sigmafine to perform a data conditioning step based on mass and energy conservation principle, resulting in reducing the inaccuracy of the oxygen measure and making the resulting dataset suitable for the use by the energy manager. So the expected correlation appears. We have seen the importance of achieving a more reliable and accurate dataset, but we have learned that it is extremely important to provide a measure of how much reliable and accurate the dataset is. This is provided by a set of data quality indicators calculated by Sigmafine. Some of them, like the overall imbalance indicator, are model-oriented and provide a general measure of how the overall system of measurement involved behave over time. These and other model-based indicators are often used to provide a trackable justification basis to demonstrate the compliance to authorities, such as the one related to the SOX Act and to environmental agencies. Other indicators are generated per each piece of a measurement involved in the model. The measurement correction indicator is used to rank meters and provide an early detection of bad measurement to be put under investigation. So the capability of measuring our dataset is the foundation to be able to monetize the information gain we can obtain by transforming our data and put in place a sustainable practice of continuous improvement. With that, I would like to summarize again the Sigmafine mission, which is to implement a repeatable and sustainable practice for transforming process and manufacturing data into digital asset with the objective to create a positive economic value for our customer. We in Pinsoft are not alone in doing this. Sigmafine is sustained by an ecosystem of customer, partners, and industry experts who are with us along this data transformation journey. And today you will listen to the story by Astron Energy, by our trusted partner Rifleshot, and several Sigmafine use cases from different industries by Velisha.